Located at Maindy Park in the heart of Cardiff, the new Innovation Centre Spark is the door to innovation at Cardiff University and will provide cutting-edge facilities that will help researchers and students work across disciplines and with partners to influence policy and build businesses that create products, spin-outs, startups and social enterprises. Within the Translational Research Hub, Bouygues UK is providing new Cleanrooms for Cardiff University, built from scratch under highly complex conditions. Led by industry and academia, the Institute for Compound Semiconductors is an innovative collaboration between IQE plc and Cardiff University to underpin the creation of a unique global capability for new and emerging 21st century technologies. Based in Cardiff, the Institute for Compound Semiconductors represents a unique opportunity to build on the university's creativity and excellence in research to develop an innovative ecosystem to commercialise next-generation opportunities. The Compound Semiconductor Centre is a vital milestone towards developing a world-class compound semiconductor cluster in South Wales.
My role here initially was to look after the logistics and the site setup. As the job progressed further, I was responsible for certain areas, so the cleanroom suite and microscopy. The cleanroom is an environment that's completely controlled to minimise the amount of dust and particulates that are within the airspace. Here it's for microelectronics and the creation of semiconductor wafers.
CMB were appointed in late 2018 to work with Bouygues to deliver the facility. We started designing the project in early 2019 and started developing a lot of the design and the detailing with the client and the Bouygues team and the various consultants.
I'm Peter Smoten. I'm the director of the EPSRC Future Compound Semiconductor Manufacturing Hub, which is essentially a consortium of several universities and industry partners doing research. I'm also the director of the Compound Semiconductor Manufacturing Centre for Doctoral Training, which is a PhD level training activity. And both of those two things are really involved in research into the manufacturing processes for these semiconductor materials and devices, which basically underpin all of the technology that we use now. It's a specific sort of clean room, a semiconductor fabrication clean room, and what it allows us to do is part of the compound semiconductor manufacturing process. We actually take in a semiconductor wafer, that's essentially a semiconductor crystal, and we do the 3D structuring of that crystal to create functionality. Now, I guess an analogy for that is if we take a block of marble, that's the semiconductor wafer, we would then do the sculpting of that marble to create the form that might be the statue. But we actually do a bit more than that because we also add extra materials such as insulators and metals to create circuits in that semiconductor chip. And those chips are then of a size that you could fit into, for example, your smartphone.
So it's a specialist area of construction because the environment's got to be right for the end user once we finish the construction of the space. So we had to implement a lot of controls early on in the build process to make sure that it was going to be correct at the end. So we had to control the PPE, we had to pressurize the environment from an early stage to make sure no particulates settled within the area. In terms of the build process, we had to make sure that the steps were complete early enough that we didn't have to go back and rework certain areas because that would have created dust and particulates. So there was a whole host of challenges that we encountered throughout the build, but hopefully we've got where we need to be and we deliver a good project at the end that's usable for the client.
Where we've added value to the project is not only have we done the traditional mechanical and electrical installations, we've also engaged with a series of very highly specialist contractors, and together with the experience we've gained from other complex and similar projects in the semiconductor industry, we've been able to integrate them seamlessly into the rest of our installations and delivered a turnkey solution, including some very, very highly complex systems such as the ultra-pure water, the specialist gas systems. A lot of them are toxic, a lot of them are hazardous, some of them are pyrophoric, which means that effectively they ignite in contact with oxygen. And we effectively developed a lot of the detailing to do with the safety and the coordination, because it's an extremely congested site. and we really sort of developed the detail in collaboration with the client in order to sort of give them the facility that they wanted.
Compound semiconductors are very similar in crystalline form to silicon, but they simply use different atoms and many more different types of atom. And put together, those give you enhanced functionality and actually some functions that you can't get with silicon. And examples of enhanced functionality are they'll operate much faster. That gives you faster transistors, for example. And they'll also give you functions like being able to emit light that silicon can't do. So we can make compound semiconductor lasers.
So the ISO classifications, as I mentioned, we need to achieve ISO classification 5. So ISO 5 permits 100,000 micrograms of particulates within a cubic meter of air. And just to give you an idea for scale, a microgram is a millionth of a gram. Because of our strict protocols and certain aspects of the construction, so we've got an ISO classification 3. So we're actually better than what we needed to be.
Actually, it's going to be an open access facility, a pay-to-use open access facility for anybody from in the UK that's suitably trained. Those people they'll be supported by our engineers, or actually they can actually pay our engineers to do the tasks for them. I think the Cleanroom will act as a magnet to small companies that also want to use the other facilities of the Cardiff Innovation Campus. It'll attract the highest level academics and industry partners to create a centre of excellence. It'll co-locate people, or help co-locate people from very different backgrounds. And of course, diversity is what leads to innovation and new ideas and new ways of thinking. And it will also act as a support for the South Wales Compound Semiconductor Cluster and other initiatives such as Net Zero. And of course, compound semiconductors really play a major part there in things like energy efficient lighting and as the switching elements in electric vehicles.
It's quite satisfying to have studied at Cardiff University and then sort of still working for the place where I was educated, where perhaps I got all or most of my engineering knowledge from as a starting point. So it's been incredibly satisfying and fulfilling to be able to deliver that role within Cardiff University on a facility as prestigious as this.
Well, obviously, personally, I'm very excited about this. This is an enormous opportunity, but I think I mentioned earlier about the compound semiconductor cluster in South Wales. What we're trying to do there is to create a world-leading cluster. And this facility is a key ingredient of that compound semiconductor cluster. So what we're aiming to do is to bring companies and researchers to the UK, to Cardiff, because of this facility.
It's been a massively rewarding project for me personally. Just seeing the faces of the people that are going to go in and use the space and knowing that it's going to be a fantastic facility for Cardiff University is really rewarding.